Hello students, I am Dr. Nimi Singh. Today I bring you a learning module in BSc Forensic Science on behalf of the content writers Dr. GSOD and Ms. Tulika Banerjee on an important unit of forensic ballistics, which is firearm evidence. Now this is the fifth part in which we will discuss about automatic firearms, its principle and their different types of mechanisms. We will wind up this module with the examination of automatic firearms. Now let us start our module with a look at what we are going to learn today. The first is going to be the introduction of the topic. Second would be the principle of automatic firearms. Third would be the three mechanisms of automatic firearms. First one, the blowback action mechanism, then recoil operated mechanism, and then the third, gas operated mechanism. Then we will study the principle of firearm examination, and then the examination of automatic firearms, and we will conclude in the end. In the older times, the firearms were muzzle loaders in which the projectiles were loaded manually from the muzzle end, and the complete projectiles, which were usually spherical in shape, used to coast out of the barrel and leaving no residual casings, also known as cartridge cases. These initial weapons could have been little more than mental constraints, being inept, sluggish to fire and difficult to target. In addition, rain or humid weather conditions had an adversative effect on the priming charge, making it unmanageable to ignite. But as soon as the development of firearms materialized, the cartridges were started to be loaded by other mechanisms which are probably not manual. The power to operate an automatic breech must obviously be self-contained within the weapon and comes from either the push of the recoil, that is, the direct utilization of the gas pressure on the head of the bolt, or the expansion of the powder gases and the energy stored in springs for the performance of the counter recoil and loading operation. A firearm may have a repeating mechanism. The firearm has a magazine to house two or more cartridges. Extraction, ejection and reloading are done in a single manual operation. Some shotguns and most of the old bolt action service rifles belong to this class. Pump action shotguns also belong to this class. An automatic firearm has all the qualities of a self-loader. In addition to this, after firing the first shot, the firearm automatically goes on firing cartridges as long as the trigger is kept pressed and the magazine is not exhausted. Some pistols, submachine guns and machine guns belong to this class. They often have an arrangement to change them from automatic to semi-automatic action also. Some examples of automatic firearms are submachine guns or carbines. These are automatic guns provided with an alternative semi-automatic arrangement. For example, Zitara multipurpose carbine, submachine gun, carbine 9mm ZAI, which is a silent version, Thompson submachine guns. Then you have light machine guns. Bren gun is a light machine gun. It is an automatic weapon with a caliber of 0.303 inches. Coming to the machine guns, Vickers machine guns has the same caliber as that of Bren gun, but is effective at a greater range. Then we have AK-47. This is a Russian assault rifle having a caliber of 7.62 millimeter. The Russian design of the assault rifle AK-47 is being manufactured throughout the world in varied modified versions, and terrorists are making extensive use of them everywhere, including India. AK-74. AK-47 has been extensively modified in Russia to give birth to this new kind of assault rifle, namely AK-74. The caliber of AK-74 has been reduced to 5.45 millimeter, which has resulted in becoming it more lethal because it can cause severe wounds. As soon as the trigger of the firearm is pressed, it releases the hammer or striker with a considerable force. The striker compresses a pressure sensitive material contained in the percussion cap. This generates a hot piercing flame which ignites the propellant charge. The charge quickly transforms into gas, and due to limited space in the cartridge, the large volume of the gas so produced develops a very high pressure. The pressure so developed forces out the bullet or the shot charge through the barrel towards the target. While the bullet moves forward, the cartridge case is pushed backward. The case therefore comes in contact with the firing pin and the breech face of the breech block and picks up marks from their surface. The cartridge case, which also expands the round due to the tremendous pressure developed in it, comes in intimate contact with the chamber and sometimes may carry chamber marks. The fired cartridge case is extracted out of the chamber by an extractor and then ejected out of the firearm by an ejector. Now, in this process, both the extractor and the ejector are likely to leave marks on the cartridge case, in which the mechanism automatically extract and eject the fired cartridge case and loads another from the magazine into the chamber, thus making the weapon instantly ready to fire another cartridge practically as soon as the preceding cartridge has been discharged, but does not fire it. To fire, the trigger must be released and then pulled and pressed for each and every shot. This mechanism is followed in case of semi-automatic firearms. On the other hand, an automatic action is one which continues to fire as long as the trigger is kept pressed. Thus, an automatic firearm is one that loads fires, extracts, ejects and reloads, continuing the cycle as long as the firing mechanism is held in proper position. Let us first discuss the blowback action mechanism. In blowback action, there is a heavy breech block. It moves backwards and forwards in a receiver attached to the barrel. It is not locked to the barrel. There is a strong spring behind the breech block called the counter recoil spring or return spring. When a cartridge has been loaded in chamber and during firing, the breech block is not locked to the barrel. Before we discuss the operation of this mechanism, let us consider for a moment the gas pressure inside the barrel. When the cartridge is fired, the pressure rises to its peak value, and when the bullet is moving forward inside the barrel, the gas pressure goes on reducing, and when the bullet is just about to leave the barrel, the gas pressure is about 1/4 of the maximum pressure. When the bullet has just left the barrel, the pressure in the barrel reduces to 0, but for a moment there is some pressure inside the cartridge case, which is called the residual pressure. In bolt action firearms, the bolt closes the rear end of the barrel and can be locked to the barrel during firing, but in blowback action firearms, the heavy breech block is not locked to the barrel during firing. When the cartridge is fired, the pressure acts in all the directions. The pressure acting at the base of the bullet moves it forward, while the pressure acting on the breech block through the head of the cartridge case moves the breech block backwards. But this backward motion of the breech block is slow because it is very heavy in comparison to the bullet, and also because there is a strong return spring behind it. By the time the bullet has left the barrel, the breech block moves to the rear, but a very short distance of about 1/8 inch. Now, when the bullet has left the barrel and pressure has dropped, the breech block continues to move backwards because of the momentum it has gained and because of the impetus of the residual pressure. The fired cartridge case is extracted and ejected. If the firearm is hammer fired, it gets cocks also. The return spring gets compressed. It forces the breech block forward. When it moves forward, it takes the live cartridge from the magazine and loads it in the chamber. If the firearm is semi-automatic, then the trigger has to be released and then pressed again for firing. But if it is fully automatic, it will continue to fire till the trigger is kept pressed or the magazine becomes empty. This action is employed in submachine guns. Coming to the second mechanism, that is the recoil operated mechanism. Now, the recoil operated action is mainly used in pistols. Here, the bolt and the barrel are firmly locked together at the instant of firing. When a firearm having this action is fired, there is a high pressure inside the cartridge case. The barrel and bolt both move backwards. After the bullet has left and the pressure inside the cartridge case has reduced to a safe value, the barrel and the bolt separate. The barrel moves to its original position, but the bolt continues to move backwards because of the momentum it has gained and because of the impetus of the residual pressure of the propellant gases inside the fired cartridge case. The fired cartridge case is extracted and then ejected. Behind the bolt, there is a counter recoil spring because of the background motion of the bolt. This counter recoil spring gets compressed and the firearm gets cocked also. The cartridge is loaded into the chamber and the firearm becomes ready to be fired again practically as soon as the previous cartridge has been fired. The recoil operated firearms are of two types: short recoil operated firearms and long recoil operated firearms. Now, short recoil operated action. In this type of mechanism, the breech block is locked tightly to the barrel. The barrel and the bolt are arranged to slide backward together on firing through a tube which encircles the barrel and a grooved well in the receiver. Thus, when the rifle is fired, the barrel and the bolt slide straight to the rear, actuated by the recoil, during which the movement of counter recoil is compressed. When the barrel has completed a certain shot travel to the rear and the bullet has left the muzzle, the barrel is stopped, and at this point the breech block or bolt is unlocked from the barrel by cams in the receiver. In some designs, a counter recoil spring is provided for the barrel and the spring then pushes it forward again to its normal position, but the momentum and the residual pressure still continue to act. The compressed counter recoil spring then moves the bolt forward, carrying the top cartridge from the magazine into the chamber and the bolt locks itself to the barrel such that the firearm is ready to be fired again. Examples of this mechanism are 0.45 caliber Colt automatic pistols, Johnson rifles, LMG Logger, P38 Walther and Mosser pistol. The Johnson semi-automatic rifle is the most efficient utilization of this system. Coming to the long recoil operated action. In this type of weapon, which is represented by the Remington auto loading shotguns and the rifles, barrel and the bolt recoil all the way solidly locked together. As they do so, they compress their respective return springs. The returning of the barrel and the breech block are separated. When the recoil is completed, the bolt is caught hold by a catch. As the barrel begins to move forward, it is unlocked from the bolt, which remains held to the rear portion and which removes the empty case. In this type of weapon, the extraction and ejection results in the removal of empty cartridge case from the chamber and then finally from the firearm. When the barrel is almost moved fully forward, it trips the catch, releasing the bolt which comes forward, feeding a new cartridge. The breech block and the barrel move backwards for the distance in axis of the cartridge length. Thus is the case of a weapon firing a 2.5 inch case. The barrel movement is in the region of 3 inches. This is the principle behind the Browning self-loading shotguns. The chief objection to the recoiling system is the sliding barrel and the excessive number of parts. The barrel requires a tube around it, within it which it recoils, and the tube retains heat excessively. The well is fitted to the barrel but must be secured to the tube and receiver. The barrel cannot be a perfect fit in its tube, and slide for it would not operate if dust is present, and this will necessarily result in variations in aiming. The recoiling action is timed by regulating the weights of the barrel and breech block and by the strength of the springs. If the barrel is heavy, it will have too much inertia. Then its recoiling speed will be very slow and ejection efficiency may be reduced. On the other hand, a heavy breech block tends better ejection because it loses its momentum less than a light one after it has separated from a barrel. Coming to the third mechanism, that is the gas operated mechanism. This action is used in most of the high velocity rifles like AK-47, 7.62 millimeter self-loading rifles, etc. In this action, there is a small hole in the barrel which exerts pressure on a piston. The piston is connected to a bolt. This bolt gets unlocked from the barrel and moves backwards when extraction and ejection of the fired cartridge case takes place. The counter recoil spring pushes the bolt forward, loads a live cartridge from the magazine into the chamber and gets locked to the barrel. The operating rod and piston also move to their original position. The firearm can now be fired if it is the semi-automatic mode, but if it is automatic mode, it will continue to fire till the trigger is kept rest or the magazine gets empty. Some automatic firearms have a selector switch having 3 modes: safe, semi-automatic and automatic. The automatic mode firearms have 3 cartridges with 1 pull-off trigger. The rod of this piston pushes back an operating rod which is connected with a bolt and a counter recoil spring. The operating rod first operates a cam to rotate a bolt and unlock its lugs, by which it was tightly locked to the barrel, and then pushes the bolt back, extracting and ejecting the fired cartridge case, compressing the counter recoil spring and cocking the firing pin. The counter recoil spring then pulls the bolt, operating rod and the gas piston forward. As the bolt moves forward, it pushes the topmost cartridge from the magazine into the chamber and firmly locks itself to the barrel, such that the firearm is ready to be fired again. The parts of a firearm which come in contact with the cartridge or bullet are firing pin, the breech face, the extractor, the ejector, the chamber and the barrel. They are made of steel by cutting, hammering, filing, reaming and polishing. The tools used in their manufacture are applied at random. The cutting surface of the tools used continue to change because of wear and tear they suffer due to their action on steel. The finished surface of the relevant portions of all firearms is therefore never alike, even when the two surfaces are made with the same set of tools one after the other. Consequently, all firearms possess an individuality of their own. This has been established by actual experiments which are carried in the initial stages of the development of this science. A long barrel was bored and grooved with the same set of tools. It was then cut into 6 pieces and fitted to 6 firearms. The bullets fired through the 6 barrel of those 6 firearms were correctly identified in respect of the individual barrels of the 6 firearms. The peculiarities of the surface of a firearm are enhanced with the use of the firearm because of wear and tear and accidental damage. When a cartridge is fired, the irregularities of the surface imprint their pattern on the case or the bullet because of close contact under pressure. These patterns are also called thumbprint of the firearm and permit their individualization. The cartridge cases and bullets are usually made of comparatively softer metal than the material used in the manufacturing of the firearm itself. The marks produced on surfaces therefore do not change substantially for thousands of shots, and the fired ammunition can be identified even when the firearm is recovered after a long interval. However, if the firearm is ill kept, misused or intentionally tampered with, the surface may change. The extent of variations will depend upon the changes so made. The fired ammunition may or may not then be identifiable. Each case has to be decided by actual experiments. In a murder case, the firearm was buried underground for many months. It was still possible to identify the fired bullet only after it had been carefully cleaned and in spite of the fact that the firearm had rusted extensively from outside. Sometimes very old firearm is used in the commission of crime. Due to extended use over long periods, the barrel of the firearm gets washed and also its bore becomes larger. A bullet fired through such a firearm does not house properly in the barrel, and hence it is not imprinted with identification marks, that is the thumb print of the firearm. Generally, this does not happen during the interval between the occurrence of the crime and recovery of the firearm. Some criminals use previously fired bullets in cartridges of higher caliber. For example, 0.325 bullet is placed in a 12 bore cartridge and fired. This misleads the investigating officer. he searches for a rifled firearm rather than a shotgun. It further complicates the investigation. If a cartridge of lower caliber is fired through a firearm of higher caliber, its bullet does not fit in the barrel and often does not take identifiable marks. If some marks are discovered on the bullet, they are then compared with a fire test bullet of the same caliber as the firearm. In some cases, it indeed gives a useful match, but sometimes a loose bullet is marked imperfectly and the test bullet of the right caliber does not give correct match. In such cases, a lead bullet or a slug which is specially prepared of slightly larger diameter than the bore is pushed through the barrel. It takes up most of the marks from the barrel and provides useful test material. Now, there are two types of characteristics, that is class and individual characteristics or marks. The position, size, shape and depth of firing pin, breech face, extractor, ejector and chamber marks on a fired cartridge case constitute class characteristics, while the finer details in the marks give the individual features of the firearm. Similarly, the number, width, depth, direction and pitch of the lands and grooves on a fired bullet indicates a class characteristic of the firearm, while finer details in the lands and grooves are individual characteristics of the firearm. Class characteristics are common on the ammunition fired from the firearm of the same make and model, but they differ with different makes and of different models of the same make. Individual features are so named, they are always different and no two firearms have the same characteristics. The class characteristics are useful only in quick eliminations. The nature of a firearm and possible make is indicated by the class characteristics. This indication is useful when the firearm is not recovered immediately and there are a number of suspects. It is already known that firearm has been classified into several types and hence one of the classifications include the automatic firearms. Furthermore, it is important that during the examination of firearm evidence, it is known that which type of firearm has been used in the commission of crime. If it is an automatic firearm, then one should know the various mechanisms by which such type of firearm operates. Also, while the examination of such type of firearms is carried out, the class and individual characteristics need to be studied for.